The National Electrical Code, or NEC, contains specific guidelines for tap conductors. A tap conductor is a conductor that branches off from a larger feeder conductor. These tap rules are designed to ensure the safety and proper functioning of electrical systems. One of the primary rules governing tap conductors relates to their ampacity, which is the current carrying capacity of the conductor. The NEC specifies that the ampacity of the tap conductor must meet certain minimum requirements relative to the overcurrent protection device protecting the main circuit. A common tap rule states that the tap conductor must have an ampacity of not less than 1/3 of the rating of the overcurrent device protecting the circuit. This rule applies when the tap conductor does not exceed 25 feet in length and certain other conditions are met, such as being suitably protected from physical damage and being terminated in a single circuit breaker or set of fuses that will limit the load to the ampacity of the conductor. Another tap rule, often referred to as the 10-foot tap rule, allows for shorter tap conductors, typically those not exceeding 10 feet in length. In this case, the tap conductor's ampacity must be not less than the sum of the calculated loads served by the tap conductors and not less than the rating of the overcurrent protection device at the termination of the tap conductors. It's important to note that the tap conductors must be enclosed in a raceway when they leave the enclosure. There is also a 25-foot tap rule that allows for longer tap conductors, up to 25 feet in length, under specific conditions. For the 25-foot tap rule, the ampacity of the tap conductor must be at least 1/3 of the rating of the overcurrent device protecting the feeder. The tap must terminate in a single circuit breaker or a single set of fuses rated to protect the tap conductor's ampacity. The tap conductors also must be protected from physical damage by being enclosed in a raceway. When applying these tap rules, it's crucial to consider the specific details of the installation, including the length of the tap conductors, the ampacity of the conductors, the rating of the overcurrent protection devices, and the type of loads being served. Understanding the National Electrical Code requirements for tap conductors is vital for ensuring safe and compliant electrical installations. In a specific scenario presented, a distribution panel with an 80-amp breaker feeds a junction box with number 6 copper wire. From the junction box, 2 taps are made using number 10 copper wire, each approximately 6 feet long, terminating in fusible disconnects with 30-amp fuses connected to an air conditioning load with a full load amperage of 22.8 amps. The inspector required the replacement of the 80-amp breaker with a 60-amp breaker, citing a violation of the tap rule. The core issue revolves around whether the number 10 copper tap conductors protected by 30-amp fuses at their termination comply with the NEC tap rules, given the initial 80-amp overcurrent protection device. Let's analyze the situation using the common tap rules. Firstly, consider the 10-foot tap rule. If the number 10 copper tap conductors, which have an ampacity of 30 amps, are not more than 10 feet long, their ampacity must be not less than the calculated load and not less than the rating of the overcurrent device at the termination of the tap. The load, in this case, is the air conditioning unit with a full load amperage of 22.8 amps, which is less than the 30 amp ampacity of the number 10 copper conductors. The overcurrent protection at the termination of the tap is provided by 30 amp fuses. Since the tap conductors are 6 feet long, it would appear this condition is met. However, the ampacity of the tap conductor needs to be not less than 1/3 of the rating of the overcurrent device protecting the main circuit in some instances. Since the original breaker was 80 amps, 1/3 of 80 is approximately 26.667 amps. Since the number 10 conductor is rated for 30 amps and the tap conductors terminate in a fuse disconnect sized at 30 amps, this would also meet this part of the requirement. The problem is not with the 10-foot rule in this case, however. It does point out one thing. The conductors that are the tap conductors need to be protected at their ampacity where they terminate. Secondly, consider the protection of the tap conductors. Number 10 copper conductors typically have an ampacity of 30 amps, assuming they are insulated with a common insulation type such as THHN and are installed in an environment with an ambient temperature of 30 degrees Celsius. The tap conductors are protected by 30 amp fuses in the fusible disconnects. This means that the tap conductors are protected at their ampacity, which is a requirement for tap conductors. The issue here is that the tap conductors are connected to an 80 amp overcurrent protection device. The requirement that might be violated is the one that deals with the overcurrent protection of tap conductors relative to the overcurrent protection of the primary circuit. As mentioned before, the tap conductors must have an ampacity of at least 1/3 of the overcurrent device protecting the primary circuit. If the original breaker was an 80 amp breaker, then the 1/3 rule would require the tap conductors to have an ampacity of at least 26.667 amps. Since the number 10 copper conductors have an ampacity of 30 amps, this condition would be met. In this case, the inspector likely determined that the 80 amp breaker was not providing adequate overcurrent protection for the number 10 tap conductors. This could be based on several factors. One possibility is that the inspector was concerned that the 80 amp breaker would not trip quickly enough in the event of a fault in the tap conductors. Another possibility is that the inspector was concerned that the 80 amp breaker would allow the tap conductors to be overloaded for an extended period of time, which could damage the conductors or create a fire hazard. By reducing the breaker size to 60 amps, the inspector ensured that the tap conductors were adequately protected from overcurrent. Another important consideration is the load connected to the tap conductors. In this case, the load is an air conditioning unit with a full load amperage of 22.8 amps. The NEC requires that the overcurrent protection device be sized to protect the load. In this case, the 30 amp fuses in the fusible disconnects would provide adequate overcurrent protection for the air conditioning unit. However, the inspector may have been concerned that the 80 amp breaker was too large for the load. By reducing the breaker size to 60 amps, the inspector ensured that the breaker was sized appropriately for the load. Here's a summary of the key points regarding tap rules. Firstly, tap conductors must meet specific ampacity requirements based on their length and the overcurrent protection device protecting the main circuit. Secondly, the tap conductors must be protected from overcurrent at their termination point, typically by a circuit breaker or fuses. Thirdly, the overcurrent protection device must be sized to protect the load connected to the tap conductors. Finally, local codes and interpretations may vary, so it's always best to consult with a qualified electrical inspector or engineer. The inspector's decision to require the replacement of the 80 amp breaker with a 60 amp breaker was likely based on a combination of factors, including the ampacity of the tap conductors, the size of the load, and the need to provide adequate overcurrent protection. By reducing the breaker size, the inspector ensured that the electrical system was safe and compliant with the NEC. It's important to note that electrical codes and regulations can be complex and may vary depending on the jurisdiction. It's always best to consult with a qualified electrician or electrical engineer to ensure that electrical installations are safe and compliant with all applicable codes and regulations.